Hello students, let's see how to solve locus problems part 2, an easy approach. We're going to discuss JEE main examination questions based on locus problems as shown here, but first the method you have to follow. First, you assume the point as h, k in each problem. Secondly, use the condition given to relate h and k. And finally, replace h by x and k by y to get the required answer. Now, in the first question we see, if the locus of the midpoint of the line segment joining 3, 2 to the points on the circle x squared plus y squared equal to 1 is a circle of radius r, what is r? So we start with point A given, which is 3, 2, and let's assume the point B as x, y, which is any general point lying on the circle. And h, k is the point whose locus has to be found. So first of all, we use the condition given in the problem, which says it is the midpoint, so h is x plus 3 by 2 and k is y plus 2 by 2. Now we need to get an equation in h and k, and for that we find x in terms of h and then y in terms of k. Now we can say that x, y is a point lying on the circle. It lies on the circle x squared plus y squared equal to 1. Putting these values in this equation, we get the equation which relates h and k as this. We can further simplify by taking 2 common from the equation, and it changes the form like this. We can divide both sides by 2 square in the next step and replace h and k by x and y, so that we get equation like this. Now comparing it with the center radius form of circle in the standard form, we can very easily see that the center is 3 by 2, 1, and the radius is 1 by 2. Right, so answer is 1 by 2 as asked by the question. So now we go to the next question, which says locus of the point which divides the line segment joining 0, minus 1 to any point on x squared equal to 4 in the ratio 1:2 is. So we start by assuming the point A as 0, minus 1 and point B as a point lying on the parabola x squared equal to 4y. Now P, the point whose locus has to be found, is h, k. So this sketch shows the location of all these points and the ratio in which h, k is dividing A and B. Using this section formula, h can be written as 1 into x plus 2 into 0 by 1 plus 2, and k can be written as 1 into y plus 2 into minus 1 by 1 plus 2. So h is x by 3 and k is y minus 2 by 3. Now once again, getting x and y in terms of h and k, we can write x is equal to 3 times h and y is equal to 3 times k plus 2. But the point x, y, it lies on x squared equals 4y. So putting these values in equation, we get an equation in h and k like this. We finally do the step as we know, replacing hk by x and y. So 9x squared is 12y plus 8, and hence 9x squared minus 12y is equal to 8 is the final answer, which is option A here, right? So we go to the next third question, which is locus of the midpoint of the perpendiculars drawn from the point on the line x is equal to 2y on the line x equal to y. Now, to solve this question, we must know a result regarding the foot of perpendicular drawn from x on y1 on the line ax plus by plus c equal to 0, as shown in the figure. So we have alpha minus x1 by a equals beta minus y1 by b equals minus of ax1 plus by1 plus c upon a square plus b square. So this gives us alpha, beta, the point which is called the foot of perpendicular from the point x1, y1 upon that line given. Let a point on x is equal to 2y be x1, y1, which can be written as 2y1, y1, since x is equal to 2y. From this point, we'll drop a perpendicular on the line y equals to x. Now how to find that? We'll use the result as given above. So the foot of perpendicular from this point on the line y equals to x, or rather x minus y equal to 0, will be found like this. We put alpha minus 2y1 by 1 and beta minus y1 by minus 1, they are the coefficients of x and y, and equals to minus of 2y1 minus y1 upon 1 square plus minus full square. As per the result, we get this. We can further simplify this. You will get alpha minus 2y1 equals to beta minus y1 by minus 1 equals minus y1 by 2. Now, we can get the value of alpha from here as 2y1 minus y1 by 2 because of the first and third, and then beta is equal to y1 plus y1 by 2, second and third equating them. You get alpha as 3y1 by 2 and beta as also 3y1 by 2. Now, let hk be the midpoint as mentioned in the question, midpoint of x1, y1 from where the foot of perpendicular is being drawn, and alpha beta, the actual foot of perpendicular. Right, so the points are 2y1, y1 and 3y1 by 2, 3y1 by 2 as we calculated just now. The midpoints are having coordinates h, k, so h is 2y1 plus 3y1 by 2 whole upon 2 and k is y1 plus 3y1 by 2 whole upon 2. This way, we get two relations, that is h is equal to, how much? Let's calculate. It is going to be 7y1 by 4 and k will be equal to 5y1 by 4. Now we have to get the relation between h and k as you studied in the beginning. So what do? You find y1 from both these equations and equate them. You get h by 7 equals to k by 5, which means 5h is equal to 7k, or 5h minus 7k is 0. Replace h by x and k by y, you get the final answer, which is 5x minus 7y equal to 0. You look up the answers and this is the first option, we get the answer. Let's go over to the next question now, fourth question, which says a is 0, 6, it is a fixed point, b is 2t, 0, it's a moving point, m is the midpoint of AB if perpendicular bisector of AB meets the y-axis at C. Locus of the midpoint of MC is, we start with putting a equals to 0, 6 and b as 2t, 0. Now the midpoint M will be given by section formula or midpoint formula, as you see, you get it as t, 3. Once you get this, now we find the slope of the line segment AB. Using the slope formula y2 minus y1 upon x2 minus x1, you get this result minus 3 by t. Now since we have to find the equation of the perpendicular bisector, we find the slope of the line perpendicular to AB, which is going to be t by 3, simply because M1, M2 must be minus 1 for two perpendicular lines. So once you get the slope of line perpendicular to AB, and we know that it passes through the midpoint M, we can write the equation of perpendicular bisector line. The equation will be given by this expression, y minus 3 equals to t by 3, x minus t. Okay, now question says it intersects y-axis, so we'll put x equal to 0 to get y, so y comes out as 3 minus t square by 3. Now C point will be this, because this is the point where it cuts the y-axis. Now M point was t, 3. We have to find the locus of the midpoint of M and C, so let HK be the midpoint. So once again, we are going to use section formula for midpoint of these two. So H and K are the coordinates of that midpoint. H is 0 plus t by 2 and K is 3 minus t square by 3 plus 3 by 2. The two equations again. And now you can find t from the first one, which is 2h, and put it in the second expression, which is k equal to 3 minus t square by 6. When you replace t by 2h here, you get expression like this. Now you need to just simplify to get an equation in terms of h and k, which you can get very easily like this. Even keep on simplifying, ultimately you get this expression. Replace h by x and k by y, you get the final answer. Get ty equals to 9 minus 2x square, which can be simplified and written as 2x square plus cy minus 9 equals to 0, and that is the final answer to this question. Let's look up the answer key options. Let's see. So you see that second option is the right answer. Let's go to the fifth question. Let's see with the locus of mirror image of the point on the parabola y square equal to 4x about the line y equals to x. Equation of the tangent to C at the point 2, 1 is. Okay, so first of all, we need to find the locus of the mirror image of the point on the parabola. Let HK be the image of the point x comma y, which lies on the parabola. Now, since image above the line y equals to x, we know that h will become y and k will become x. Why? Because a comma b has the image about y equals to x as b comma a. Right. Only the coordinates have to be reversed to take the image about y equals to x like here. Now, this way we get these two equations. Now we know that x comma y lies on y squared equal to 4x. So we put back the values here. H squared will become 4 times k, and hence x squared equal to 4 times y is going to be the curve which is obtained as image. Right? As shown in the question. Now the next task is to find the equation of tangent at the point 2, 1 on this curve. So equation of tangent can be found simply by putting capital T equal to 0. If x1, y1 is the point lying on the curve T equal to 0, gives you the equation of the tangent. That will be x1 minus 2 y plus y1 equals to 0. Putting the points coordinates 2, 1 here, you get the equation as x into 2 minus 2 times y plus y1 equals to 0. That gets you x minus y minus 1 equals to 0. So that is going to be the final answer to this question. This is the third option. Okay. Next we go to the sixth question, which says P is a variable point on y equals to 4x squared plus 1. Then the locus of the midpoint of P and foot of perpendicular from P on y equals to x. Okay. So let x1, y1 be the point on y equal to 4x squared plus 1. And let alpha comma beta be the foot of perpendicular from this point x comma y on the line y is equal to x. Now we'll find the value of alpha and beta using the relation here and here. This here used in the question earlier also, as you might have seen. So this expression gives you the value of alpha and beta, which is the foot of perpendicular as asked by the question. This alpha is x1 plus minus x1 plus y1 by 2, and beta will be a y1 plus x1 minus y1 by 2. Simplifying them, you get alpha as x1 plus y1 by 2 and beta also as x1 plus y1 by 2. So these are the values of alpha and beta, which is the foot of perpendicular as asked by the question. Now, A is x1, y1 and the point B is alpha comma beta, which is the foot of perpendicular from E on y equals to x. Now, let h comma k be the midpoint as asked in the question. We define the locus of the midpoint. So midpoint will be, using the midpoint formula, it will be x1 plus alpha by 2 and k will be y1 plus beta by 2. This gets you, in the next step, x1 plus x1 plus y1 by 2 as the h, and k is y1 plus, again, x1 plus y1 by 2 whole upon 2 as k. We need to solve now these two for x1 and y1. So let's simplify these equations and write them as these two equations, and then we can add them up to get 4 times f1 plus y1 is 4 times h plus k, which means x1 plus y1 is equal to h plus k. And now we can solve for x1 and y1 in terms of h and k as x1 equals to 3h minus k by 2 and y1 is equal to 3k minus h by 2. So now we put the values of x and y1 in the original equation, that was y1 is equal to 4x1 squared plus 1, and we get a relation as shown here. Simplifying it further, as you can see here, we can get the final equation of locus as required by the question. So you collect the terms on one side and then replace h and k by x and y, so that you get the final answer as 2 times 3x minus y whole square plus x minus 3y plus 2 equals to 0. So that becomes the final answer for this question, which is option number 2. Subscribe the channel not to miss the next part of the locus problems from JEE Mains examination coming soon. Thanks for watching.